Hello everyone, welcome to my YouTube channel. Today we are going to see what is embedded interface and how we can use them. So this is going to be part 1 of the embedded interface series. There is another major advantage of using embedded interface which we are going to explore in my next video. So stay tuned for that. I have already made a couple of videos on interfaces in Go and how to use them. So if you haven't already seen them, please go and watch them. I will also link them in this video's description. Also, I am making a playlist of all the Go related tutorials that I'm going to put here so that you can easily find them and watch them together. I will also add a link to that playlist in this video's description. So without further ado, let's begin. So before starting with embedded interface, the first question that comes to our mind is, what is it? What is embedded interface, right? So embedded interface is a very simple concept, and it is what exactly it says. That is, it is embedded. So in this case, we are going to explore when an interface is embedded in a struct, how it can help us. So a struct, as you know, can have many types of member variables within it, and it could be int, it could be string, it could be float, anything, any data type. It could be an interface also. So when an interface is defined as a member variable in a struct, it's called as embedded interface. So what is the benefit of using it? What is the use case? Where should we use it, right? So the first major advantage is unit testing. And we are going to see in today's video how it helps us in unit testing. So let's go to our VS Code and start our main.go file. So this is just the beginning of the program, and I'm going to define very simple main function. So the use case for today's lesson is something like this. Suppose there is a person who wants to do a course in Golang. So he needs some money to join the course. So who does he go to ask for the money? Usually it is going to be the father, isn't it? So there are two objects in this use case. One is the student who wants to learn about Go language through the course, and another object is going to be his father. So let us define those two objects. So we are going to say type student struct, and another one is his father. So type father struct. Okay. So the student is going to ask for money to his father, right? So let's create that function. So func ask for money, and it is going to get the money from the father. That means we need a relationship between father and student, right? So let's do that. So we have made a relationship now. So student now has this father. So student asks to his father to provide the money, right? So let us define a function which for the father struct, which is going to be the definition of giving the money to the student. So let's say func. So this is going to be the father, and let us say give money, right? So let's say he is going to give 100. So let's make it integer. So 100. Okay. So now I can call this function give money, and then how much money I'm going to get for the course. So let's return through an integer. So it's FM, the money given by father. So return FM. Okay. Now let us say that the student has some money from his savings. So let's say savings int. So whatever is the money he saved, he is also going to put that money for his course. So instead of doing FM, we can do FM plus s dot savings, right? So very simple. Father is always going to give rupees 100. Student is going to receive it along with his own savings. So let's see that. So we're going to say first student. Let's say his savings is 50, and also we need a father object. So this is going to be student and father, and here we are going to pass the father. So f is okay, and then we are going to print it 20.println and s dot ask for money. So let's see. I want to give it a different name, so let's say gather money, because he's not only asking it, he's also giving some money himself to the fund. So gather money. Now let's run this. So here, let's say go run money.go. So 150, this is what we expected. Now if I want to test this function gather money, if it is returning the correct value or not, how do we do it? We need to write a test file, right? So let's do that. So main underscore test.go. Oh, by the way, when you are going to write a test file, you need to give it a name underscore test. So that's how Go identifies that it's a testing file. So I created this file. So let us do the basic stuff first. And since it's a test function, so we are going to say test gather money, right? Gather money. It's going to be using start t of testing, right? Now let's define this. So we'll do the same thing. Let's copy this gather money. So instead of doing this, we're not going to print it, we need to test it, right? So in this case, we're expecting it should be 150. So let's take that value. So let's say result. So this should match 150, isn't it? So result, if it doesn't match, that should be an error. Let's say error values did not match, right? Okay, so let's run this. As you can see, it's correct. So if I make it 200, which it should not be, it will give us a failure. So this is what we expect. Okay, all is good and fine till here. Now the problem is, if I want to see that, let's say that this give money returns us as something different, some value different, like I don't know, 200. So that should be 250 in that case, correct? But we do not have that option to do that right now. We cannot say it to return some specific value for us for testing. But ideally, a unit test should test all the possible scenarios. So this is where we are failing in doing so. So that means this structure is not correct from a unit testing perspective. So what can you do in this case? what we can do is take help of interfaces. So as you already know, if we have one interface, we can implement the methods defined within the interface through different structs, right? So right now we are using father. So if I create another struct with a different name, that can also implement the same method defined within the interface, and then we can return our own value. Through that methodology, we can return any value that we want, right? So let us see that in action. So let's say type, let's say sponsor, right? Sponsor interface. Sponsor is going to sponsor the student with the money. So father could be a sponsor, right? So that's fine. So I'm going to say this, give money int. So let's see if this still works. Let's make this sponsor. So father is a type of sponsor. So that's why we need to take the address here, because I'm passing pointer. So it works here, right? So now if I run this program, go run main.go, it still works as we expect. Now let's see the benefit. So suppose since it's an interface, I can write my own struct type. Let's say, I don't know, another sponsor or mock sponsor. Better, mock sponsor. So this is a struct, and then mock sponsor is going to implement the method that we defined within the sponsor interface. So let's copy paste this part, and let's say mock sponsor, right? Then we are going to return 200. Now here, instead of taking father, we would say mock sponsor. Should work, because mock sponsor is also a type of this interface, right? So we can easily use it, and it's working. So I say that in this case, return 200. So 200 plus 50 should become 250. 250. Let's run this. Voila, it's matching. Here, if I say 150, it's not going to work, because this is not calling this implementation, rather this implementation. So this is how we can return any value that we want, and against that value we can test different scenarios, and we can be sure that it is this function gather money is doing exactly what we want. It's actually getting the money from this function, and then it is adding the savings with the value returned from this function. So this is how embedded interface can help us with unit testing, and it's really helpful in this sort of scenarios. So hope this makes sense to you guys, and hope it's clear. Do let me know in the comment section if there is something I can improve upon, and if there is any suggestions that you have. Also, if you want to learn about something specific, some specific concept about Go language, please also comment it out in the comment section. And do like, share, subscribe, the usual stuff, no need to mention, I think. And thank you for watching the video. See you in the next one. Bye.